Okay, let's go ahead and get started. So topic one is the first topic we're covering today. It's on exponential functions for growth and decay. I know that sounds scary, but it's actually not too bad. So our learning goals, I want you guys to be able to match situations with the appropriate exponential function. I want you to be able to classify exponential functions as either increasing or decreasing. And then I also want you to be able to write your own exponential function to model a situation. Okay, so I just want to go over some vocabulary first. The first word I want to go over is simple interest. So this is a type of account that you can have. So in a simple interest account, a percent of the starting balance is added to the account at each interval. The formula for simple interest is, and this is I equals P times R times T, where P represents the starting amount. So let's say you open up a bank account and you have $100, $100 would be P. That's your starting amount. R represents your interest rate. So every account will have a different interest rate. And our interest rate, I just want to make a note, we always express it as a decimal. So we want to change our percentage to a decimal. T represents time, and then I represents your interest earned. Okay, so let's go ahead and continue. Oops. All right, the second type of account you can have that we're looking at for this lesson is a compound interest account. The balance is multiplied by the same amount at each interval. The formula for compound interest is, and then for this one, it's I equals P times 1 plus R to the T. And then this is what everything represents. So it's essentially the same thing. So P is the starting amount, it's the principal. R represents the interest rate. Again, it needs to be expressed as a decimal. T is the time invested, and then I represents the final amount, including your principal. Okay. All right. So here's just a problem. So it says, suppose that your family deposited $10,000 in an interest-bearing account for your college fund that earns simple interest each year. A friend's family deposited $10,000 in an interest-bearing account for their child's college fund that earns compound interest each year. So the first account here is a simple interest account, and the second one is a compound interest account. So in the comments, go ahead and type in what account you would prefer. So would you prefer for your money to be in a simple interest or a compound interest account? And while you're doing that, I'm going to take attendance. Okay, good. So a lot of you guys are saying compound interest. I don't think anyone has said the simple interest account. So for those of you saying compound interest, I'm assuming, I'm not going to have you unmute yourself just because I'm recording this. But if you look over time, you could see that the compound interest account, you're able to raise more money, okay? And we're going to talk about why you're able to do that in a little bit. So let's move on. We're going to get into some examples in a little bit. I kind of just want to throw the formulas at you. We have two more formulas. They're actually not too bad to remember. The only difference is one has a plus in the middle, the other one has a minus, and it's kind of self-explanatory. The first one is an exponential growth function. An exponential growth function has a b value greater than 1. Now, keep in mind that when I say b value, I'm talking about this number here, because if you remember, our formula from last time for an exponential function is a times b to the power of x. So this b is being replaced by the 1 plus r, okay? So r is the rate of growth, and b value is 1 plus r. Again, the rate is always, 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 always expressed as a decimal. I'm going to make a note of that here. So this needs to be a decimal. Okay, an exponential decay function has a b value greater than 0 but less than 1. Okay, this could be a fraction, This could be a decimal, and keep in mind that not all decimals are less than 1. So again, when it's talking about the B value, it's talking about this here, okay? It has to be less than 1. R is the rate of decay, and the B value is 1 minus R, okay? Again, the rate needs to be expressed as a decimal, so we're going to see some problems where we don't have a decimal and we need to turn it into 1, okay? So these are formulas. By the way, on your quizzes, it's open note, which I would assume that you're probably using it anyway, because it's not like I can see you taking your quiz. But you are able to use your notes, so don't stress about memorizing these. Just use the formulas that I'm giving you. You just need to know how to use them, okay, and when to use them. Okay, so let's get into some example problems. So it's saying match each situation with the appropriate function. So here are your functions. It says Blueville has a population of 7,000 people. Its population is increasing at a rate of 1.4. Okay, so that's number 1. Number 2 says Youngstown has a population of 7,000. Its population is increasing at a rate of 1.2. And then number 3 says Westlake has a population of 7,000. Its population is increasing at a rate of 2.8. Okay, I'm going to do some of these problems first, and then I'll have you jump in as you feel comfortable. So notice that for all of these, it says that the population is increasing. Okay, so what I want to do, these are my answer choices. The first thing I want to do is eliminate the ones that are decreasing. Okay, so what I want to do is look at my B values. So remember, the B values, think of your exponential function. The B value is going to be anything that's raised to the power of x. Okay, so these are all B values. And remember, your B value is increasing if your B value is bigger than 1. Okay, so I'm going to look through these. And just by looking at the first one, okay, that number is not bigger than 1, 0.969. So I'm going to cross that out because I know that's not increasing. Okay, for B, I know that is greater than 1. And another way I can tell is I have a plus there. It's 1 plus 0.028. And when I add that, it's going to be bigger than 1. So that could be an answer. For C, my B value is bigger than 1. So I know that's increasing. That could also be an answer. D is decreasing. And I know that because I have a minus in between. Okay, so I'm going to cross that one out. Okay, there's one more that's decreasing that we can cross out. So in the comments, type which function is decreasing. Which one can I cross out? So which function is decreasing? Would it be E or F? Okay, perfect. Yes, you guys are all right. It is F, and I know that because it's less than 1. Okay, so I'm going to erase some stuff because I've gone crazy and have written all over everything. Okay, so B, C, and E are our answer choices for these. Okay, now take a guess. If I had to pick one for number 1, which one do you think I would pick? Would you pick B, C, or E? Okay, perfect. So you guys are all saying E, and it is E. And the reason that it is E is because if you actually plug this in or substitute into the exponential growth or decay, in this case growth model, we would have, sorry, I'm trying to write with the eraser. We would have y equals a times 1 plus r to the power of x. Now, remember I talked to you about converting this to a decimal. I know a lot of you know how to convert to a decimal, but for those that don't, I'm just going to go over it really quick. To convert 1.4 to a decimal, 1.4%, you take the decimal and you move it to the left 2 spaces. So 1, 2, there's my new decimal, and then you add a 0. So this would be 0.014, okay? So what you could do is now take that and substitute it into the r. So it's going to be y equals, A is going to be 7,000. So that's 7,000 times 1 plus 0.014 to the x. Okay, and then when you add this together, 1 plus 0.014 is just 1.014, okay, which is exactly the option for E. Okay, perfect. So this one's E, so I used that one already. For number 2, you have 1.2. Go ahead and in the comments type which one that would be. Is it going to be B or C? Perfect. It is C. And then the last one is obviously going to be B. Okay. Before I move on to more examples, do you guys have any questions on anything we've gone over so far? If you do, please ask now. You can type it into the comments or unmute yourself. If you don't, you can give me a thumbs up, or you can type it into the comments saying that you're okay. Okay, good. So you guys are saying you're good. Let's go ahead and move on. All right, so for this next page, it's continued. So for all of these, it's number 4, 5, and 6. And for all of these, if you read through them, you could tell that the population is decreasing. Okay, so we're obviously not going to use E, C, and B because those are the ones we used already. So I'm going to cross those out. E, B, and C. Okay, so we're left with A, D, and F. All right. Okay, all of those are decreasing. I think D is the easiest one to start with, and I'm choosing D because it hasn't been subtracted yet. It's written as 1 minus 0.017. So what I'm going to do is you could either convert this to a percentage, so 0.0175, you can move it over to the right one 2 times, so it's going to be 1.75%. And the problem that has 1.75% is number 4. So I know that D is the answer to number 4. Okay. And then for the other two, you have A and F as options. Now you have 0.969 and then you have 0.9875. So what you want to do is actually work one of these out to see which one gives you A or F. So let me show you what I mean by that. So for number 5, you have a rate of 3.1. So again, you want to convert that to a decimal. So I'm going to do that. So I'm going to move this to the left 2 times, add a 0 here. So this is really an R value of 0.031. Okay. And now what you want to do is substitute it into the exponential decay function because this is a decreasing situation. So I'm going to have y equals, my A value is 7,000 times 1. For decay, it's minus. For growth, it's plus. So I'm going to have 1 minus 0.031 and then to the power of x. Okay. Remember I said you can use calculators, so use a calculator. So you can subtract 1 minus 0.031. And when you do that, you get y equals 7,000 times, and then when you subtract that, you get 0.969 to the power of x. Okay. And then obviously by looking at the choices, this is choice A, so I can cross that one out. And the only one left is choice F for the one at the end. Okay, so this is how you match functions. Again, just going over it really quickly. You could tell if a function has a growth or decay by looking at the B value. Okay, so by looking at the B values, the B value will tell you if it's increasing, if it's greater than 1, or if it has a plus in between. You could tell it's decreasing if it's less than 1 or if it has a minus in between. Okay, we're going to move on to the next topic, but before we do, are there any questions? Okay, last chance to ask questions on this stuff. So in the comments, let me know if there are any questions. If you're good, give me a thumbs up. And if you don't, we can move on. Yes, I can slow down a little bit. Okay, so here, let me erase some of this stuff. Okay, so for the choices, I'm going to highlight the positive ones in green. So I know this one is going to be an increasing function, and I know that because of the plus sign in the middle, okay? Whenever you have a plus, that means it's increasing, okay? So I'm going to put a plus because it's increasing. I know that C is also increasing because your B value, so all of these are B values. this b value is bigger than 1. Like if I actually add the numbers from this one here, that's going to be a number bigger than 1. It's going to be 1.028. So if the b value is bigger than 1, it's going to be an increasing function. Like this one, 1.012 is obviously bigger than 1. It's increasing. And then the last one that's increasing is e. That's 1.014. Okay, the other ones are decreasing. I'm going to highlight those in red because the b value is less than 1. So anything that's less than 1 is decreasing. Now here, this hasn't been subtracted yet, but because there's a minus sign, I know 1 minus anything is going to be less than 1. You can actually subtract it if you want to. That's going to be decreasing. And then the last one is also less than 1, so that's going to be decreasing. Does that answer your question, Salvador? And then anybody else? Does anyone else have? Perfect. Does anyone else have any other questions? All right, so these examples are super important. So just make sure that you look at this page when you're taking your quiz, because these examples could really, really help you out. Remember, it's an open note quiz. I didn't multiply anything, Alan, so I subtracted. So you take your rate, which is right here. Here's my rate. Okay, they gave it to me in my problem as a percent. I converted it to a decimal, and then you substitute it into the exponential decay model. So the exponential decay model is in the formula sheet that I gave you. So I just substituted it in. So it's 1 minus your rate. And then when you subtract those, that's when you get your answer. Does that answer your question? Okay, perfect. All right, I'm going to go ahead and move on. All right, so that's exponential growth, exponential decay. For topic 2, we're going to interpret parameters in context. So our learning goals for this part is I want you guys to be able to analyze equations and graphs of exponential functions. I want you to match equations and graphs of exponential functions using the horizontal asymptote. And then I want you to write and interpret exponential growth and decay functions. So this all ties back into exponentials, which we learned last class. So if you weren't here, you're probably a little lost. So you need to go back and watch the recording for that lesson. Okay, so this first situation is matching. Okay, so I have graph 1, graph 2, graph 3, and graph 4. For the sake of this assignment, I'm going to label my equations. I'm going to call this equation A, B, C, and D. So what I want to do is match each equation to a graph. Okay, now for these equations, you really want to think about the general equation of an exponential that I gave you last time. It's y equals a times b to the power of x plus c. In the comments, please tell me what c represents in this exponential. Tell me what c represents. So what does c represent in an exponential function? So in the comments, go ahead and tell me what c represents in an exponential function. And as you're doing that, I'm going to take attendance again. Okay, so if you're saying minor step, you're not right. Don't just copy what people say. Remember, it's open notes, so if you have your notes from yesterday or you have your homework, you can look back. All right, so Jaime has it. It's the horizontal asymptote. So here is your A. Your A is your y-intercept, okay? Your B is your constant multiplier, and then your C is your horizontal asymptote. And I told you yesterday that for all the examples, it was going to be y equals 0, but now we've made it to a point where it's not y equals 0 anymore, okay? We have different horizontal asymptotes. So for the first one here, my horizontal asymptote, just look at the end, look and see what's being added or subtracted. For this one, it's 2, okay? Now, if I'm looking at all my graphs, I can easily tell what graph this goes to by looking for my horizontal asymptote, okay? And I know that the graph that matches A is going to be graph 2, and I know that because there is a horizontal asymptote at 2, okay? So 2 is right there. Let me use a pen instead. So at 2, your graph gets really, 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 really close, but it never crosses that line, okay? So that's how I can tell that graph A matches with graph 2. So this one goes with graph A, all right? Using horizontal asymptotes, see if you can match the B, C, and D, okay? So see if you can match those. Don't type it into the chat yet, but just use your horizontal asymptote to see if you can match the rest of the graphs to the equations. Okay, so don't type it into the chat yet, but I'll let you know when. So if you want, you could start typing it in, but don't press enter yet. So see if you can use the horizontal asymptote to match. So when you type your answers in, like kind of like the one I just did, for example, you could do graph 2 goes with A. Okay, and then you could do that for the other graph. So just type it in, but don't submit yet. I'll give you guys another minute. Jerry, not yet. Okay, go ahead and type them in. Hey, you guys, I'm seeing really good answers. If you haven't answered, make sure you do so you get participation. Even if your answer is wrong, you'll get participation points. I'm not looking for right or wrong. I'm just looking to see that you're trying. Okay, perfect. So for graph 1, you guys should have gotten A. We did that one together. Sorry. For graph 2, I'm sorry. For graph 1, it goes up to 5, so that one's going to be C. Okay. For graph 3, it goes down 3, so that one's going to be D. And then for graph 4, this one goes to 0, and you can tell here that if you don't have anything, remember it's plus 0, so this one's going to be B. Okay, so those should have been your answers. Congratulations if you got it right. You're also going to have a question like that on your quiz on Friday. Okay, any questions about asymptotes and how to match using an asymptote? On your quiz, you'll just be using asymptotes to match. So your examples would be just like this one. Okay, it looks like you guys are okay, so I'm going to move on. Okay, so our next problem is a word problem. We're going to practice a little bit more of our formulas. So example 1 says Autumn received a graduation gift of $1,000 from her wealthy aunt. She placed this money in a savings account with a 4% interest rate compounded annually. Okay, remember you can use your formulas. So it says write a function f of x to model this situation, define your variables. So the first thing I'm going to do is, I know that this is a compounded annually problem, so I know I'm going to use that formula. Okay, so the formula I just copied from above is going to be I equals P times 1 plus R to the power of T. Okay, and then I'm going to start highlighting some stuff. So I'm going to highlight what's important. So one thing that's important is $1,000. That's how much money she started with. And then she has a 4% interest rate. Okay, now, again, remember your rate always needs to be a decimal. So I'm going to change this to a decimal. So if there isn't a decimal there, it's going to be after your whole number. So it's after 4. You want to move it to the left 2 spaces. So it's going to be 1, 2. Your decimal goes there. That's going to be 0.04. Okay. So now I can use that information and plug it into my equation. Remember that they told you to call your function f of x. So I'm going to say f of x equals, my P is my principal. That's how much money you invested. She invested $1,000. So it's going to be $1,000 times 1 plus 0.04. That's my rate. And then to the power of T. Now, instead of using T, I'm going to use an X because my function is f of X. If it was f of Y, I would use a Y. If it was f of Q, I'm going to use a Q. In this case, it's X. Okay. Any questions on how to write your model? If you do, you can unmute yourself or type it into the chat. And remember, the formula I just took from the notes above, so you can look at those later. Okay, I'm going to move on. So part B is asking, what will the balance be in Autumn's account after 5 years, 10 years, and 15 years? Okay, so for this part, you can actually, I put a couple links at the bottom of the page. You can use Desmos. So Desmos, not only does it do graphing, it also has a scientific calculator. So here is my Desmos opened up. So this is Desmos Scientific Calculator, and you can look at those links later. But I like using this because you could type exponents into it and it'll calculate for you. Okay, so the first thing I'm going to do is type my equation in. I'm going to not type in the f of x because that's not important. So I'm going to have 1,000, not 100, times 1 plus, my rate is 0.04. And this is to the power of x, okay? But they're asking me to calculate how much money she has after 5 years. So instead of putting x, I'm going to put to the power of 5, okay? So I could see here that she has $1,216, and I'm going to round, so I'm going to do and 65 cents. Okay, so that's how much money she'd have. So if they ask how much money did she have after 10 years or 15 years, I'm just going to change that 5 to a 10 or 15. I could even check how much money she'd have after 20 years. Okay, so you could see that amount of money growing. Okay, I'm going to show you how to do the exponent. So on this, for your exponent, all I'm doing is I'm pressing the caret symbol on my keyboard. So if you look, like not on here, but on your actual keyboard, above the number 6 is a caret. That's what I'm using. Okay, so you can use a caret symbol and it'll raise you up. And then that's when I'm putting my number 5. Okay, what I want you guys to do is I want you guys to open this page in another tab. So in another tab, go ahead and type in Desmos. So desmos.com/scientific. So open up another tab. And go to www.desmos.com/scientific. All right, and then I want you guys to try to do the same thing, but compute how much money she has after 10 years. Okay, so I'm not going to show you my right-hand side of the screen. I want you to try to compute it, and then I'll have you type the answer into the chat. Don't type the whole number in. Make sure you round to a number that makes sense with money. So you want to have your number and then 2 numbers after the decimal place for cents. Okay, so go ahead and try that now. I'll leave this on the screen in case you need to go back and see what the function is. So go ahead and try typing this into Desmos. If you have any questions on how to use Desmos or how to type it in, now is your time to ask. You can also ask after class. Okay, perfect. So I see the answer coming in the comments. You could type your answer in too, or you can go back and just make sure that you get the same answer so you know you're doing this right, because you will have a question like this on your test. So make sure that you're able to use Desmos correctly. Okay, good. These all look really good, but if I had to be super picky on a test, I would just make sure that you add in your $sign. So just add your units, okay? Are there any questions on this problem? Okay, perfect. So you got exactly what I got. So 14.80 and 24 cents. Okay, now try the same thing after, so don't close it yet. Try it after 15 years. Let's see who gets it first. So after 15 years, see how much money she would have. Yes, Cassandra, even with the $sign, perfect. She's the only one that has a dollar. Oh no, Dorian has a $sign too. Okay, perfect. So you should have $1,800.94. Perfect. Okay. So that's how to use Desmos. So you can use that on your homework. All right. Okay. And then the last part of the question is to estimate when Autumn will have $1,600 in her account. Okay. So $1,600. Now, in Math 1, you don't know how to solve exponentials yet, so you can't do it by solving, but you could do it by looking at a graph. So what I'm going to do is now I'm going to go to Desmos graphing. Okay. You could follow along. So if you do want to follow along, you could go to desmos.com/calculator, and you could do it in another tab and just kind of look at both my screen and your screen to make sure that you're doing the same thing. So if you do want to follow along, I'll give you a moment to get yourself into Desmos graphing. So it's desmos.com/calculator. Or you could even just type in Desmos graphing into Google and just click on like the first link that comes up. Okay, so if it's asking you how much time will it take for it to get to 1,600, what you could do is type in your equation, okay? So I'm going to type it in, f of x equals 1,000 times 1 plus 0.04, and then again, caret, so to the power of x, okay? So if I zoom out, I could see my graph, okay? And I mean, this is tied into the same section because it's obviously an exponential function. So it's asking me, when will she have $1,600? Whenever it asks you that, you want to look for it by looking at your y-axis, and you want to go up to 16. Was it 1,600? Yeah, to 1,600. Okay, so 1,600 is right here. You just touch the point to see where it is about. So I would say it would take about 12 years, okay? Because that number is so close to, it's 11.987. So for that one, I would just answer 12 years. If it asks how long will it take for her to get to, I don't know, let's say 1,700, then you would go all the way up to 1,700. And you would say, oh, it would take about 13 and a half years because it's about 13.551, okay? So that's how to approximate. Do you guys have any questions on using Desmos graphing or Desmos calculator or anything that we've done so far? If you guys are good, you guys could give me a thumbs up. Or you can unmute yourself too if you have questions. Okay, perfect. It looks like a lot of you guys are good. So let's move on. Again, I put the links to the PowerPoints to both of these sites. So if you ever want to go back and you forget, you can click on those. All right, we're almost done, you guys. Our next slide. So it says, Autumn also saved $500 that she keeps in a safe at home, okay? She never spends or adds to it. So she just has $500. Your mom probably has money saved under her colchon. She just throws her money under there, or in her little drawer, like with her socks, she like keeps her money in there. Okay, so we're gonna see the difference between keeping your money at home versus putting it in the bank. So it says, write a function g of x to model the situation. Now let me ask you guys a question. Would I use any of my formulas for compound interest or simple interest if someone is keeping their money saved at home? Is anyone paying interest to them? So do you think I would use one of those formulas? So go ahead and say yes or no. Okay, yes, perfect. You would not. So if you have $500 saved at home, this is what your formula is going to look like. So nothing's being added to it. It's just going to be g of x equals $500. Okay, so that's Autumn. She has $500. Okay, or your mom has $500 under her colchon. Okay, for those of you that don't speak Spanish, that's under her mattress. Okay, for part B, it's asking how much money is she going to have after 5 years? So after 5 years, how much money is Autumn going to have? What do you guys think? If she never adds to it or takes anything away. So you could type it into the comments. Perfect. She is. She's going to have $500. What about 10 years? What about 15 years? Is that amount of money ever going to change? Perfect. It's not. She's always going to have $500. Okay. If she keeps that money there, she's going to have $500. And it's asking you to estimate, when is she going to have $1,600 in your safe? So how would you answer part C? Estimate when she's going to have $1,600 in her safe. Perfect. I see never. She won't ever have $1,600. She can't. Exactly. You guys are all correct. She's not going to have $1,600 unless she adds another $1,100 to it. Victoria, you're absolutely correct. She won't have that money unless she herself adds to it. So, okay, let's keep that in mind. So now it's saying, what equation can be used to represent her total savings? So let's say that her aunt did give her $1,000 and she put that amount of money in the bank. And then she also has $500 under her colchon at home. Okay, it's asking what's her total amount of money. So if you want to know the total amount of money, this is what you're going to do. You're going to take whatever amount you have in the bank, which is my f of x, and you're going to add whatever money you have at home, which is g of x. Okay, so let me show you what that looks like. So let's call her new function h of x, just because. Okay, so it's going to be her f of x plus g of x. Okay, and I'm going to label this. F of x is whatever's in the bank, and then g of x is whatever is at home. And you can add them together. Okay, so let me show you how to do that. So I'm going to move over to the side because I'm a terrible planner and I left myself no space to do this problem. So I'm going to take f of x. So f of x was 1,000. So I'm going to say h of x is my new function. This is her total amount of money, is equal to 1,000 times 1 plus 0.04 to the power of x plus the amount of money she has saved at home, which is 500. So this is her total amount of money saved. Please do not combine things because you cannot. Okay, so this is her total amount of money saved. Okay, now let me ask you guys a question. If I was to graph this, where would the horizontal asymptote be? Where would the horizontal asymptote be if I graph this? Ooh, you guys are saying the right number, but you're not writing it correctly because that's not how we write a horizontal asymptote. How do we write a horizontal asymptote? You guys have the right number. Perfect, time it's y equals your number, y equals. So at y equals 500, that's where the horizontal asymptote will be. Perfect. And then another question. Let's see if anybody gets this. Where would my y-intercept be? My y-intercept. And make sure you put it in the right notation. And remember, y-intercepts are written like this, if I can spell correctly. Okay, so trick question, brownie points. Where would my y-intercept be? Perfect. You guys are so smart. You make me so happy. Yes, it's 1,000. Okay, so for those of you that are like, how did they get 1,000? Remember, this is your A value, and your A is your y-intercept. This is my C value. And then another question, okay, because I can't trick you guys. What would my multiplier be? What's my constant multiplier for this function? So in other words, what's my B value? So you can write it as B equals. And careful, it's not 0.04. You're so close. What's my multiplier? It's not 1. You guys are both really close. If you actually combine those, it'll give you your answer. See if anybody gets it. It's not 1.4. You added those wrong. These are funny. Yes. Okay, let me see. Yep, you guys got it. Okay, so it's a 1.04. All right, if you add these, okay, 1 plus 0.04 is 1.04. So this is your B value. So that's how this ties into yesterday's lesson, which I think is pretty cool. Just saying. Okay, I'm weird. I'll stop. Any questions on any of this stuff? On savings? Are you guys good? Give me a thumbs up if you're good. If you have questions, now's your time to ask. Okay, it looks like you guys are good. So we have one more. This is our last problem, and then we're done. Okay. So let's just go ahead and get to it. Oscar owns a bee, or wants to own a bee colony. Sorry, let me start over. Oscar wants to own a bee colony so that he can extract honey from the hive. He starts a colony of 5,000 bees. The number of bees grows exponentially with a growth factor of 12% each month. Write a function f of x for the bee population that can be used to determine the number of bees. Okay, this is a growth problem, and it's not talking about money, so I know I'm going to use my exponential growth function. Okay, I'm not going to use my I equals formula, my compound interest or simple interest. We're not talking about money. We're going to use our growth formula, which, by the way, the compound interest formula comes from the exponential growth formula. But anyway, first thing I'm going to do is write my formula down, okay, because I know it's growth. So I'm going to say f of x, because that's what they want us to call it, is equal to, and then you want to start off with the amount of bees that you have, that you're starting with. Okay, so this is 5,000 times 1 plus my rate. Okay, so my rate is 12%. As a decimal, that's going to be 0.12. And this is to the power of x. Okay, so there's my formula, where x represents the month. Okay, it says right here to use x as the month. Okay, so it says use technology to graph this function. So when it says to do that, that's when you're going to use Desmos. Okay, so you're going to use Desmos graphing. So I'm going to take that one off and add my new one. So I have f of x equals 5,000 times 1 plus 0.12 to the power of x. Okay, so this is what my function looks like. Just by looking at it, it's in blue. I can tell it's a growth function. It's increasing as I go from left to right. I have a horizontal asymptote at 0, which makes sense with my equation. So there it is. I did part B. Let me go back to my question. Part C says, Oscar feels that in order to get a decent amount of honey, there should be at least 1,500 bees in the colony. Estimate how many months it will take for him to get to 1,500 bees. So this is just like the problem we did where we were checking to see how long it will take, what was her name? Autumn, to have $1,600 in her account. So we're going to do the same thing. So I'm going to go all the way up. Actually, it's not 1,500, it's 15,000. So I'm going to go all the way up to 15,000. Okay, 15,000 is right here. And I want to look at, let me zoom in more for you guys. So here's 15,000. I want to look at my X, okay, because that's going to tell me how many months it takes. So it looks like it's going to take about 9.5 months. It says 9.697. So I'm going to say it's going to take about 9.5 months. So here I'm going to say about 9.5 months. Okay, so you can use these equations to estimate as well. Okay, that's it for today. I just want to go over what your homework is. Any questions before we look at your homework? You can unmute yourself if you have any. Okay, so remember we learned 4 formulas today. 2 are related to money and saving money. 2 are related to exponential growth or decay. Okay, so that's how you can narrow down which one you need to use for homework. Okay, homework number 2 is on Google Classroom. Again, you need to show all work for full credit. It's due on Sunday by 11:59 p.m. Remember, I will take off the late points if it's late. Email me if you have any questions. Let's look at your homework really quick. Here's your homework. So you have another question about saving money. It's asking you to write a function to model your situation. How much money will she have saved after 10, 15, and 20 years? So you can use Desmos, the Desmos Scientific to help you calculate those if you don't have a calculator at home. Number 2 is asking you to determine whether each of these are exponential growth or decay. This is like the first problem that we did. So again, for these, make sure you look at your B values. Okay, so for all of these, you want to look at your B values, and then that's going to determine if it's growth or decay. Okay, it's growth if it's bigger than 1, it's decay if it's less than 1. For the ones with fractions, divide the fraction out to see what you get. And then for the last one, it talks about someone saving money in a bank and then saving money under their mattress at home. And then it's asking you to write a function that models their total amount of money. And then it wants you to use that to find their horizontal asymptote. So it's essentially what we did together in class. Do you guys have any questions on anything, whether it's the homework, the lesson, anything at all? Okay, if you guys don't have any questions, I'm going to go ahead and dismiss class now. So you guys are free to go. Make sure you take your quiz on Friday. If you don't, you're going to miss it and you're going to get a 0. So make sure you take your quiz. And if you have any questions and you want to stay till the end to ask, that's fine too. You're welcome. Thanks, guys. Have a good day. Thank you, you too. Do any of you guys have questions? We did take notes. I uploaded a recording of the lesson on Google Classroom. It's a link to YouTube where I recorded the lesson just like today. So you can just access it and see what we did that day.